Thank you to all of our Kong Summit 2020 partners and sponsors. Now let's get things kicked off. It's my pleasure to welcome Marco Palladino, our CTO and co-founder, and Sandeep Singh Kohli, our VP of Marketing. Take it away, gents.
Welcome everyone to the third annual Kong Summit from all over the world and from every time zone that brings together members of the Kong user community, ecosystem contributors, and industry leaders for an action-packed 2 days together.
That's right. This is the first time that Kong Summit is accessible to anyone around the world. And we are bringing this to you from the Kong headquarters in San Francisco. 2020 has been a very interesting year, and we are going fully digital. But there are actually so many benefits to this format. For one, we have speakers from all over the world that may have otherwise not been able to fly out here. And you, the attendees, get Q&A time with each and every one of them.
Not to mention, we can amplify our networking opportunities by using this platform to get matched with practitioners from every industry, each one with their own passions, like microservices, Kubernetes, or service mesh.
The goal of these 2 days is really about connections. Connections between people, ideas, and technologies. Without further ado, let's dive into it.
We explore. It's who we are. We build to move forward. We build to go further. We build to move faster, to reach the next frontier. Always asking ourselves, what's next? What's beyond? But as we touch new heights and look back on the journey, it was clear to see everything was connected all along.
Introducing Kong CEO and co-founder, Augusto Marietti.
Hello everyone, I'm very excited to be here. This is our third Kong Summit. Can you believe it? But let's go back where it all started, in 2018. Back then, we made a big statement. API management was dead. Really bold, huh? But of course, it did evolve. It did change. We have seen an explosion of services. APIs started to become multi-protocols, and architecture started to be hybrid to move this information in an easier way. And Kong, back then, gave you the service control platform. Then in 2019, we envisioned a story, a new era, 10 years down, where all the world was going to be digital connected. Data in motion is the fastest growing segment, more than data in use or data at rest. And we had to power all those connections. And back then, we turned the service control platform into a full life cycle. It was not just about building, running, and automate as a standalone entities, but we put all of those together. And we acquired Insomnia, the #1 open source testing and design tools. Also, we open source Kuma, the open source service mesh platform built on top of Envoy, now part of the cloud native computing foundations. It was a great year. We never thought though that this vision that we show you 10 years down would have come that soon. Here is 2020, what a year. We saw an explosion of everything. But really, the story is that we accelerated by 10, 15 years what the world could look like. Digital is now. Digital is here to stay. 2020, for sure, it brought us a lot of challenges. But also, there is massive amount of opportunities. Every day, we produce 2.5 quintillion bytes. And 80% of the data in the world today has been created in the last 2 years alone. This data needs to be observed, they need to be secure, they need to be reliable. I also want to show you and tell you about really 2 customer stories. Number 1, it's a multinational banking that had to provide loans faster than ever. They had thousands of SMB asking for help, and they had to accelerate time to delivery loan from 6 weeks to just 50 minutes. And they were able to do that through APIs to support all the little business so they could keep staying alive and keep working. Then, a global rental car company. When the war shut down in March, they had over 1 million vehicles spread out across the world and nowhere to be found. And once again, APIs comes to rescue, find all those cars and localize them. At one point, they were making 400,000 transactions per day. But COVID-19, it's really a catalyst for 3 major big problems. First, really the war moves 10 years forward. But the number 1 problem is that because we're 10 times digital connected, we need to build our applications 10 times faster. We need to build our digital experience 10 times faster. And how do we do that? How do we accelerate the need of now, of building digital experience today? That's problem number 1. Problem number 2, it's how do we get reliability built in? Has the world moved from centralized to decentralized? We are having a spike of traffic, a spike of services, and developer teams are getting distributed all over the place. Our architecture are looking a lot like a nervous system. It's all decentralized, spread out across all the part of your organization, your partners, and your customers. And when you do that, the control, the visibility, but most of all, reliability goes down. This is problem number 2. How do we get reliability built in? Problem number 3, it's about building a connectivity platform for the millions of developers that are the makers and the architect of next digital world. I give you a good data point. In the early 90s, there was a startup that was really building switch and routers. They were also moving traffic in the old way. And over time, they built a niche of skill set engineers and architects, and there is about 500,000 people that are working on that infrastructure. But as we move to the cloud, there is now 100 times more than that. There is 50 million developers building, and they don't want to care about connectivity. They want to build applications as fast as they can. So we have to build a platform that is for the end users, for the makers, that it's easy to use, that can support all the cloud-native applications, the thousands of those that are getting built in the next few years. We really arrive at a point that we experience life through digitals. Those digital connections are really human connections. And we have to build a platform where connectivity looks a lot like Netflix. It's always on, it's always reliable. You can subscribe and just get connectivity out of the box, on demand, whenever you want. Simple to use, that runs 24/7. It's a great concept. We have to support, to recap, 3 major problems. Number 1, it's how we build applications faster, now that the world is 10 times more digital connected. Number 2, it's really how we build reliability that is built in. And number three is how we build a platform for 50 million developers that it's easy to use. And it's not just about supporting all kind of connection, like north, south, east, west, from edge to internals, but it's about making those connections reliable. This decade is gonna run if our digital experience are reliable. Also, it's about making sure that we build a platform for everyone, not just for the niche, but for all the millions of developers that build applications today, and they want to get there faster and don't want to rebuild a connectivity platform or a connectivity grid. We have to deliver it. All kind of connection, reliable, anytime, for everyone. Today, I'm super excited to introduce you the concept of the Service Connectivity Platform. The Service Connectivity Platform really is a full stack, end-to-end infrastructure that can go from Ingress to Edge, from API management to mesh, and allows you to broker this flow of informations. Think about turning light bulbs in your house. It just works. No matter it's going to layer 4 or layer 7, no matter it's going external or it's going internal, service to service, or teams to teams. It's one unified experience that you can apply security on, you can get reliability built in, it would be easy to use, and everybody can touch it. It's a platform really built for the end user, for the architects, for the operator, for the developers. And it's gonna be full of functionality, tightly integrated to each other's, to provide you the best experience on top of many different runtimes. Whether they're proxy, they're gateways, they're mesh sidecar, it doesn't matter. It's one connectivity solution for many connectivity problems. Please join Marco on camera. He's my co-founder and CTO, and we've been working on this problem for almost a decade. He will tell you his story and his personal challenges on building connectivity as he was building different digital applications, but also he will unveil a unique product that we've been building for the last year. This product will make you the superhero of connectivity, and it's something that the world has never seen it before.
I am very excited to be here today. When Kong was first released in 2015, it changed the API world forever. Kong started the new era of cloud-native API gateways. For the first time, we had an API gateway that was this fast, this portable, this extensible, open source, that could run on Kubernetes. Kong was very different from the monolithic SOA-inspired gateways that were popular at the time. And because of this, Kong today runs on over 1.5 million instances per month all over the world. So thank you for the trust you're putting in Kong. And today, I'm excited to be here because we're going to be making a product announcement that is going to be transforming how we connect modern applications on the same scale that Kong did back in 2015. First, let's take a look at why we need this product. And let's start by exploring the single most important thing that every application must do right. Augusto already mentioned that connectivity is the future. And that's inevitable. Every time a team creates a new application, they create new connectivity. And the more decoupled and the more distributed our applications become, the more connectivity they create. The thing is, our services talk to each other a lot. If our services were people, they would never be invited at any party. They talk nonstop over HTTP, over gRPC, over Kafka to databases and so on. So let me share a story with you on how I have discovered that this was important. When I was CTO at Meshape, we were transitioning to microservices, and we were so focused on moving away from the old monolithic code base that we didn't think of connectivity as much as we should have. We thought that our cloud vendor would give us out-of-the-box connectivity that would be secure, would be reliable for all of our services. And then, once we ran our new architecture, nothing worked the way it was supposed to work. Our connections were dropping all the time, they were unreliable, they were not performant, and our services had to recover from inconsistent state every time that happened. We spent a long time building and fixing that connectivity ourselves. It was very, very painful. It's like sailing around the world and focusing on the immediate needs, the gear, the boat, but forgetting to bring food on board. And so halfway through, we're going to be having a big problem. Don't make the same mistake I made. We didn't think of connectivity until it was too late. But in a modern digital world, we succeed only when our connections are fast, reliable, and secure. Because when connectivity is down, our applications are down. And so if the application teams are building the products, and the architects are in charge of building the underlying infrastructure that's going to support these products, who is in charge of building connectivity? Is it the application teams or the architects? It is the architects. But today, in most organizations, it is the application teams that do it, in addition to building their products, which is their primary goal. So let's take a look at what happens when the application teams are building connectivity instead of the architects. An application team would start a new application, and this application may be built with different services. And so they go ahead and build these different services, perhaps in different programming languages, and eventually they will have to connect them together. And once they connect them together, they'll have to secure that connection. So they go ahead and build that. Then they'll have to route these connections, and they build routing inside of the service. Then the other service will also need to have security, and so they rebuild the same features over and over again. Eventually, they will have to log all of those requests. So they go ahead and they build that as well. But logging, it's not an isolated concern. It's a common concern. And so every service we're building is going to have that. Eventually, we want to enable requests to come at the edge. Now we have to build authentication and authorization for this application. We want to perhaps rate limit our clients, and we're going to be building that, and so on and so forth. There is lots of commonality that's being built every time by the application teams. Then we introduce new services, and all of those concerns have to be replicated across these new services as well. And then, once a new application comes in, over and over again, we're going to be rebuilding this common functionality. And then perhaps we're going to be building another app, and these applications are going to be running on different cloud vendors. When the application teams are building connectivity within their own applications, they're adding lots of fragmentation. And when we add lots of fragmentation, we add lots of problems. Perhaps we are going to be building discovery as well. And all of this will create errors in our business. This is real. Just the other day, I was talking to one of our largest enterprise customers. It's a global bank. And they were telling me how in 2018, they started a new project to transition away from TLS 1.2 to the new version 1.3, because 1.2 has a vulnerability, as we all know. And something that should have been simple for them became a multi-year journey, because they had to go and chase down every single application team to tell them to upgrade their encryption and stop doing what they were doing and focus on, making sure that the encryption was working. What should have been simple became extremely hard for them because they had no control. So we know that we're going to be having connectivity at the edge when we want to enable connections from outside of the organization to come inside. For example, from a mobile app or from an ecosystem of partners. We know that the more applications we create, the more connections we're going to be having among them inside of the organization. And we know that as we build microservices, we're going to be having more and more in-app connectivity across all the services that make up the final application. And we know that the teams are going to be doing this across any architecture they may be developing and across any platform they may be using for deploying their software. So how do we build a connectivity for all of these different use cases across all of these different platforms? And this is why today I'm excited to present to you our new product that we've been building for over a year, Kong Connect, the connectivity platform for every organization. It is full stack. It addresses all the connectivity use cases that I've just mentioned, at the edge, across the apps, and inside the apps, on every cloud and every platform, Kubernetes and virtual machine included. It is for the end users, for the architects building connectivity, and for the developers consuming it. And it's cloud native, delivered to you as a service. With Connect, we can abstract away our service connectivity the same way we use Kubernetes to abstract away our data center operations. And today, it is available to all of our customers in its beta version. I would like to invite Rez on camera to tell you more about why this is important.
Thank you, Marco. I'm very excited to be telling you all about all of Connect's capabilities today. But before I dive in and show you the product, I wanted to talk about some important changes that are happening in our industry that really make Connect the product of its time. First, at the technology landscape level. Did you know that 89% of the respondents to Kong's annual survey told us that they're going through an actual microservices change? They're changing some of their applications into a microservices architecture. And what this means is that all of the connectivity challenges that Marco outlined are actually magnifying, because every single application is becoming multiple services, multiple remote services with security needs, reliability needs that need to be addressed. CNCF's annual survey tells us that 70% of the survey respondents told us that they are on Kubernetes or containerized infrastructure today. And that means that more and more of the environments we're dealing with are actually heterogeneous. They're containerized and non-containerized. And the life cycle of all services needs to consider that. And last but not least, Gartner predicts that over $500 billion would be spent on multi-cloud environments by 2023, which means that any service lifecycle solution will need to consider multi-cloud environments. Now, not only the technology landscape is changing, the way that consumers are consuming connectivity is also changing. Now, I'm going to use a personal story of mine to illustrate this change. Around 10 years ago, when I was at Oracle and moved to MuleSoft, a big change was happening. At Oracle, the decision makers for connectivity software seemed to be very much the CIO, and the decision criteria was IT compatibility. The way the software was being installed was on traditional hardware as software package, and the purchase process took months. Now, when I joined MuleSoft, what I was noticing was a big change. More and more, the business unit executives were the decision makers. And the decision criteria was whether the software suited their business unit's needs, so closer to the end user. And more, that software was being purchased through a cloud model or a SaaS model. The purchase process was also getting simplified. Now, I believe that we're on the cusp of a major change in the way connectivity is being consumed and purchased once more. Today, more and more, the decision maker is the end user, the developers, the architects, the operators. And the criteria is, does the software meet my connectivity needs? Does it make me more productive? The deployment model is cloud native. Kubernetes, containerized infrastructure, and traditional virtualized environments across multiple clouds is what really matters. And the purchase process is hugely simplified. And the reason why I'm excited about Connect is that it is the platform that enables this type of change around connectivity. Now, as I was mentioning, the end users have obviously stayed the same, and their needs, surprisingly, have stayed the same. Developers are very much focused on business logic. Operators, they're trying to deliver a platform on which these developers can deliver their software that is reliable and has a low cost of maintenance. And enterprise architects, they're trying to decrease the time to value. So they are sitting in between the developers and the operators and trying to introduce automation and other capabilities that enables the organization to move faster and be more agile. So how can these users do this, achieve their goals in this cloud native era with the changes we discussed? We believe that around connectivity, the answer is connect. Let me tell you a little bit more about what Connect is all about. So Connect starts with our runtimes, Kong's runtimes. For connectivity at the edge and between applications, the Kong gateway and the Kong Ingress controller are enabled through Connect. And for connectivity within the application, Kong Mesh is the runtime. Now, when I say enabled through Connect, I mean that Connect enables you to deploy these runtimes on any cloud, on any Kubernetes in 100% consistent manner. And we can provision the runtime so that you manage the data plane, or we can host the data plane ourselves. Now, around Connect is a set of platform services that enable productivity for the different end users we're talking about. We start with the Service Hub, which provides a single system of record for all of your services so that they can be socialized and reused. Vitals enables observability, so you can have end-to-end visibility into the health of your services, and Vitals also integrates with existing observability solutions that are out there. The Runtime Manager is the component that enables the provisioning of the runtimes on any cloud or any environment. And Connect is integrated with Insomnia, the most popular open source tool for API debugging and exploration, which allows you to leverage the repository of services that are in Connect and have developers get going with all of that context so that they can be more productive in designing and building those APIs. And last but not least, Pordor for publishing the services with proper documentation and having a proper self-service registration process for these APIs and services. So enough slide. Let me show you a little bit what Connect is all about. But throughout these next 2 days, we're going to show you all about these services and drilling into a lot more detail. All right, well, let me start with a brief overview of Connect. What we're looking at here is Service Hub. I'm logged in as a user who's able to look at all of the services that are inventoried by the organization that I have access to. And as you can see here, there's 3 services that I have access to. Each of these services has different versions with different protocols. Now, before diving into the services, let me talk about the runtime management capabilities of Connect, because the runtimes are the components that enable the management of these services. So I'll go here to the runtimes, and you can see here, I have the list of all of the runtimes that are connected to my account here. We can see the Kong gateway runtimes, which are providing that connectivity at the edge, the Kong mesh runtimes, which are providing the internal app connectivity, and the Kong Ingress controller runtimes that are providing between app connectivity capabilities on Kubernetes. Now, interestingly enough, if you look at the Kong gateway runtimes, you can see that some are hosted by Kong and some are hosted in a self-service way. These are the data planes. So we're hosting some of them, but you can host your own and have them be connected to Connect. And we can see here the status of each of the runtimes as well. Now, of course, I can configure new runtimes as well of any of these types and decide where I want to deploy them and the deployment model as well. So this is really the engine underneath Connect, the runtimes. Now, within the services view, as an architect, let's say, I can come in and I can search any of these services using different categories. If I drill into a service, I'll see the service overview. I can see high-level information about how the service is being used, and I can see the different versions of the service. Let's drill into a specific version. You can see that this is a RESTful service delivered over HTTP protocol. We can see some vitals data being collected here, the routes that are configured, as well as the plugin that have been enabled for traffic management. Now I can come into to the spec view and see the actual OpenAPI spec that's associated with this particular version. Now, as a developer, if I may want to use this and I'm an internal user and I don't need to go through the formal portal entry, I can do that as well. Here I have open in Insomnia, and if I click this, I can just open Insomnia with all of the context. Why don't we try it? Now you can see here that the service was open in Insomnia. You can see that the design of the service was brought up. So the spec is here for me to use and see and play with. So I could use Insomnia's mocking capabilities, for example, to mock the API further as I play around with it. I can go into the debug session and actually play around with it here as well and hit the API endpoint. And of course, I could leverage Insomnia's testing capabilities as well. Now, what's interesting is that I just showed you the UI, but underneath everything that we see here is driven through APIs that's accessible through a CLI, because that is one of the important product principles that we follow here at Kong. Let me show you a little bit what the engine under the hood looks like. So we have a command line called connectctl. Let's go through and see the runtimes just like I did before. So we can see all of the runtimes that are running with my account. And actually, let me show you the account context for a second. So here I can see that I'm connected to this particular Connect account. So when I do a runtime, I'm actually seeing the runtimes that are under that particular context. Now, I can also just see a specific type of runtimes. So let's take a look at that. Runtimes of kind mesh. Now let's take a look at the services. And you can see that there is a number of services here that I can see. So let's describe one of them. I can see the details of the service right here. And what's beautiful is that I can take any one of these services and get the full history of it. So Connect actually keeps track of all change history. And the runtimes are pulling from the configuration that is in Connect. So what I could do is revert to a snapshot of a particular service version so that runtimes can revert back. So this allows me to correct any errors that might have happened by just reverting to that particular snapshot, which is great because it allows me to quickly address problems that might be happening. So of course, this UI, this CLI can be plugged into your CI/CD system to automate everything that we just saw. All right, so we just had a whirlwind tour of all of Connect's capabilities. Now it's important to remember that Connect's capabilities are built on the shoulder of giants. We started this journey with Kong, the #1 open source API gateway, in 2015. And then in 2016, introduced Kong Enterprise, a full lifecycle service connectivity platform built on top of Kong. Then came Kong Ingress, which exposed all of Kong's capabilities in a fully Kubernetes native way. Kong Immunity, which enabled artificial intelligence-driven anomaly detection for all services. In 2019, we introduced Kuma to the world, the universal service mesh, as well as our acquisition of Insomnia, the #1 open source API exploration and testing tool. And today, we're introducing Connect. Connect leverages all of the capabilities of these years of work and brings them together for a truly cloud-native experience. Now, let me introduce Kathleen DeWalk, who's going to walk us through an amazing use case at Siemens, where they're leveraging the capabilities of Kong Gateway and Kong Enterprise to its full capacity. Kathleen, please take it away.
Thanks, Reza. And I appreciate the opportunity to come talk to you guys about what is MindSphere and how we're using Kong. So let me first start just by explaining a little bit about what MindSphere is. So MindSphere is an industrial IoT platform, and we provide industrial IoT as a service. So it's a cloud-based software as a service solution, and it combines the connectivity. So we first start by connecting devices. Then we provide a number of services that you can access via API that are out-of-box functionality that gets your data, brings it into the system, high volume, high throughput, and then you can access and query that data. We also provide a number of applications that allow you to visualize the data and analyze the data to see what's really happening in your business. And beyond that, we provide the APIs so that you can build your own applications and extend the platform in any way that meets your business needs. And we provide a rapid application development environment called Mendix, and this allows you to use very low code to quickly develop new applications to extend the capabilities of the platform. Why do you use MindSphere? MindSphere gives you three things. It gives you the ability to understand really what's happening in your business. By connecting all your devices and connecting all of your products, you can really get some understanding of what's happening in your shop floor, what's happening in your products in the field, and really give you insight into what's working and what's not working for you to do predictive maintenance, for you to do process optimization and product optimization, and really give you true visibility into what's happening in your business. You can also gain experience, a unified user experience through all the applications that are available in the platform and through the MindSphere marketplace. So you can bring all these applications together, operate on your data, and extend the platform all within a single unified user experience. And it really gives you that level of transparency into your business, into the operations of your business, and into what's happening with either devices, whether you're using them in the shop floor, or products that are connected products in the field. MindSphere has over 475 partners that participate in the MindSphere ecosystem, and we have over 400 applications already in our marketplace. And this provides a particular challenge in handling APIs and in handling throughput and volume in the platform. So it's very important that we can handle the scale that we're running at. We're running at global scale. We have hundreds of gigabytes per second that we process. We connect millions of devices, and we have tens of thousands of users who are using the platform. So we're really operating at very large volume of data, but also at very large scale in both connected devices and applications and connected users. So how does it all work? So we introduced Kong as our API gateway. So from the outside world, users connect to the APIs through the API gateway to consume different APIs and build their own applications. But also external applications outside in the outside world, you can build any application and consume any API within the platform. And devices also connect from the outside world. So we have multiple types of connectivity to the outside world. Everything goes through an external facing Kong API gateway. And this provides a central way of all users, applications, and devices to access all the APIs in the platform from a single entry point. Particular aspects of security are implemented here. It checks to see if you're logged in. And so we use a lot of plugins to make sure that we have users are authenticated. If they're not, they can get redirected to authentication mechanisms. We also have quite a bit of internal traffic, so services talking to each other and applications talking to each other. And to facilitate this, what we've introduced is a second tier of the API gateway. So we have an internal communication API gateway, also via Kong. And this allows us to provide inside our virtual private network. It allows us to have internal communication, either service to service or application to application, without traversing the external facing API gateway. It allows us to do a little bit more efficient processing. Maybe we have different requirements and different plugins we need on the internal communication than we have on the external communication. So it really allows us to optimize both the external traffic into the platform as well as the internal traffic within the platform. So why do we use Kong? Well, there's a lot of key reasons why Kong is very attractive to us. First is about performance. And so by looking at a lot of benchmarks in the market, we see that Kong can perform very well and it can perform very well with low compute. And so it's partly about the performance and the scalability, but it's partly about the cost for that scalability. So we can achieve a higher throughput with less nodes and smaller nodes when we operate in the cloud, and therefore we can cost optimize the solution. Also, the ability to do non-blocking calls. Our previous implementation had blocking calls, and this allows us to operate with better performance. We also have access to a lot of plugins. So as I mentioned, we use plugins for various purposes. We use rate limiting plugins. We use authentication plugins. And this allows us to customize and extend the capabilities based on our needs. And it also supports quite a few additional protocols. So not just RESTful APIs, but we also have a need to use WebSockets for some device connectivity and bidirectional communication with devices. We also have a need in the industrial world for MQTT as a communication protocol. So the ability to extend our API gateway to support these additional protocols is something that Kong offers. These are the reasons why we switched to Kong.
Thank you, Kathleen. That's a super cool use case. Now, as you know, the foundation of Connect is built on our runtimes. And I want to introduce Shane Connolly to tell us a little bit more about some exciting announcements that we're about to make about the Kong Gateway and the Kong Ingress controller. The runtimes for managing connectivity at the edge.
As Reza was going through, you might have noticed that the version column on Connect was showing Kong Gateway version 2.2. And with that, I'm excited to announce that Kong Gateway 2.2 is here as a beta. Kong Gateway 2.2 is the next iteration of our gateway product with some really incredible new features. It's available today, like I said, as a beta, and we're planning to launch our enterprise version in about a month. Now let's get straight into the features. First, let's talk about Go. In Kong Gateway 2.0, we first introduced Golang plugin support. Golang is great for plugins because it has such a large ecosystem of modules to pull from, and then you can use and include those in your Kong Gateway plugin. This makes developing integrations in the gateway a breeze. However, when we launched the Golang support in 2.0, we started off with an MVP approach to really see how you and the community were going to use those in plugins. Now, support was limited in terms of the functionality, but that allowed us to see how you were adopting the plugin development kit in real time, and now we get to make improvements along the way with you to help you get to the next stage of your journey. And with 2.2, we've gotten to the next stage ourselves. Kong can now handle the response phase as well in Go plugins. We buffer the upstream response and now can run whatever custom logic you have in the response phase. For example, you can operate directly on the response body. Now we're super excited to see where you help us drive Golang support to next, so please do keep the feedback coming. Next, many of you will be aware of Kong support for a variety of protocols, so that no matter what sort of API you're building, Kong is there to help you meet your needs. Well, that is almost no matter what protocol you're using. One thing I know that I've learned being locked down during COVID is the importance of audio and video streaming, and maybe even a little bit of gaming. And as these services are built up, they're backed in more and more by APIs, but those APIs are a little bit different. They tend to use entirely different protocols, often based on UDP. So with Kong Gateway 2.2, we're officially launching UDP support as well. There's a variety of use cases for UDP proxying and balancing, and Kong is now here to help. Now, I'll give a bit of a demo of this in just a moment, but it should open up the door to all kinds of new streaming options for you, our users. And there's a lot more in the 2.2 gateway. I don't have time to get into all of it here today, but please do go look for the 2.2 beta, read the release notes, try it out, and let us know how you get along. I'm also really excited to announce that it's not just Kong Gateway that gets a new release. I'm excited to announce that our Kong Ingress controller for Kubernetes has just hit a major milestone as well, version 1.0. Now, to roll things back a little bit, here at Kong, we see development of our offerings based on Kubernetes as highly strategic. A number of users have been using our Kubernetes Ingress controller and been very successful in doing so. And we've recently been adding features like structured logging and moving more and more in the direction of having all of this hosted over on konghq.com, really setting us up for this milestone. Kubernetes hit a recent milestone of their own with the general availability of Kubernetes Ingress 1.0, which Kong's Ingress controller makes use of. And now Kong is hitting its own milestone with our release of version 1.0 of our Ingress controller. This is our indication to you, our community, that's been vetted for a variety of use cases. It's been battle tested and it's production ready. We hope you all get a chance to go off and try it today. Now, I'd like to do a brief demo of the UDP support that I just mentioned in Kong Gateway 2.2. Okay, great. So I'm going to create a new service here in Connect. And I've recently found out that California has live video streams of various places along the highway. And we're going to build a UDP service that's backed by one of those. So I'm just going to call this our highway live stream and our California highway stream. This will be our new service. We're going to create the service as version 1. And we're going to select the UDP protocol and enter just other as the style. Great. Now we've all got this set up and we're going to go through and add the implementation as well as a plugin. So first, adding our implementation, choose Kong Gateway. And I've got a local service hosted on a local machine. We're going to list this as 10.128.0.11 under UDP, start, and just call this an example route and get started. Great. So now I've done everything except for I need to add one more bit, which is our plugin, our logging plugin. So we'll scroll down and get to our file log plugin. I'm just going to add this to a temporary path and click create, and we are good to go. So just to show that we do indeed have our Kong gateway that's running on this host and port 10.128.0.11 port 8000, and hit refresh a few times and see that, again, no route matches with those values. And I've got a command line here, and we're just going to show that we are using, we have an open port 8000 here. That is our UDP port. And we're going to show a log file tail here as well of that same log file. And now I'm just going to go over and drag a video player and open up a network stream. And now what you see is I'm using SRT:// followed by, again, that same host and port that Kong is running on. And for those of you that are unfamiliar with SRT, SRT is a video protocol that's backed by UDP. So we're going to be routing actually live UDP data through the same, again, Kong instance that's running. And you can imagine this Kong instance could be running with REST or gRPC as well as the UDP protocol support here. And now when I click play, we get a video stream of cars that are currently crossing the Bay Bridge here, courtesy of the California Highway Video Service. And now if we go back to, again, to the log file that we were since tailing, we can see that we have a couple new entries here that show that we're getting UDP data. And you can imagine this doing any number of things, any kind of plugin that you want built on top of, again, this UDP data. And with that, again, just notice that it's the same host and port, which means that we're able to do all kinds of streaming services directly through Kong, in addition to the traditional APIs that you might have built up. Now, this is just one little example of a Kong Gateway 2.2 feature and sort of the pace at which we're innovating. And we hope that you go off and download it and install the latest Kong Gateway 2.2. And with that, I'll hand it back over to Reza.
Thank you, Shane. It goes without saying that open source is a critical part of Kong's strategy and something we believe in deeply. We believe in having products that are based on thriving open source communities. And the foundation of our open source components is Kuma, the Universal Service Mesh. So let me introduce Marco back on camera to tell us about some exciting announcements we're about to make around Kuma.
Thank you, Reza, for showing us Kong Connect. Like Reza mentioned, Connect is built on top of open source foundations. And that is because modern infrastructure is open source. It is built on top of Kong Gateway, Kuma, and Insomnia. So let's talk about Kuma. Service Mesh, it's not a siloed concern, but it is an important part of our connectivity journey. All the features that Service Mesh provides out of the box, like the zero trust security, the observability, the routing, we have to build ourselves in our applications if we do not use a Service Mesh. As part of our work with Kong Mesh, our Service Mesh product, we open sourced Kuma, our Service Mesh project, to the broader community. But we didn't stop there. We have donated Kuma and its trademark to the CNCF Foundation, making Kuma the first Envoy-based service mesh to ever be donated and accepted into CNCF. And by doing so, making it accessible to everybody with the same openness, governance, and neutrality as every other CNCF project, like Envoy, for example, which Kuma integrates with. Over the past few months, we've been rewarded with great community adoption and production usage that together are making Kuma better every day. Today, I'm excited to announce to you another important milestone for the project, Kuma 1.0, which was built thanks to the hard work of the entire community and all of its participants. Today, available for download in its first release candidate. This new release makes Kuma so much faster and more secure. With the community, we've done countless of improvements with a special focus on performance, security, analytics, multi-cluster and multi-cloud deployments. This is in addition to the mature foundation that Kuma already provides out of the box, with 10 plus policies ready to use, like mutual TLS, like observability, like routing, like tracing, like metrics, in combination with the best multi-cloud and multi-zone deployment that the industry has ever seen, across both VMs and Kubernetes deployments. And because Kuma is multi-mesh, we can deploy one cluster of Kuma to create as many isolated meshes as we need for each team or each application. And this in turn reduces the team coordination, as well as it improves security when managing the service mesh. And now, I would like to invite on stage Luca Maraski, a Kuma user and Kong Mesh customer, to tell you more about it. Welcome, Luca.
Thanks, Marco, and I want to start with thanking the whole Kuma community for this fantastic milestone. I'm Luca Maraski. I'm the VP of Engineering at CTO.ai, but before that, I was a Chief Architect at Telos Digital. And both environments seems pretty divergent, different. One being a startup and the other being a well-established telco with thousands of employees and millions of customers. However, both share the same drive, accelerating the path from concept to market while reducing the logistical complexity. And in order to accomplish this, simplicity has been one of the core principles to streamline adoption on one side and ensure on the other that governments can be enforced without actually putting any friction or interfering with the delivery velocity. The service mesh comes into play and introduces an overlay network which allows us to centrally and consistently manage distribution of policies and capabilities across systems which are more and more becoming widely distributed and federated. And I can say that I tried many service mesh, but none are as good as Kuma. But let me walk you through why Kuma won against other contenders, like, for example, Istio. And we all have been there, right? Kuma is way easier to install and to get started with. And some of these main points is that the Kuma and Kong are a match made in heaven, as they work perfectly together, with Kong leading as clearly the best-in-class experience for API management and development, and Kuma seamlessly takes care of east-west traffic, delegating Kong the very hard work or north-to-south traffic. And if on one side Istio supports just one mesh per deployment, in an organization of any size and specifically scale, when the journey to microservices transformation is ongoing, it is a great practice to divide and conquer, right? But also within the structure of the delivery teams, not only of our services. And that's when the multi-mesh support becomes an extremely important feature that allows an organic scaling of pattern and practices transversely across the organizations. In this time of cloud transformation, right, while we are all part of this journey, the adoption of major transformation processes within the enterprise, even small realities need to support an hybrid approach. And Kubernetes is on one side the de facto leader in containerization. But for many still mission critical operation, we are running on virtual machines. And that's when the native first class support for both virtual machine and Kubernetes environments, Kuma helps progressively cloud transforming legacy environments while seamlessly support business as usual. And last, with the growth of distributed and federated environments, and consequently also of development teams, the need to a centralized control plane capable of transparently and seamlessly manage and coordinate the hybrid workload in a multi-zone setup, right? Because we are distributing, is becoming increasingly foundational in any modern architecture. Telemetry, observability, policy control, service coordination, and infrastructure federation are then brought to a different level of accessibility and management. What before was seen as an inevitable cost for any development and delivery team is now transformed into a commodity, accessible in a simple and transparent way to anybody. Kuma, in my opinion, is the clear representation that simplicity is the ultimate sophistication. And with these words, I would love to give the camera back to Marco.
Thank you, Luca. Luca touched on a very important feature that Kuma provides, and that is the multi-zone deployment. With Kuma, we can support multiple clouds, multiple platforms, multiple clusters together into one large service mesh. We can also mix and match hybrid Kubernetes and virtual machine workloads. There is usually two different challenges into running a distributed service mesh. One, how do we propagate all the service mesh policies across each one of these different zones? And second, how do we discover and connect services across a multi-zone deployment? And with Kuma, we do both of these operations out of the box in a seamless way. So let's not talk about it. Let's see it in action. I'm very excited to show you this demo. In a multi-zone deployment, we're going to be having one global control plane of Kuma that is going to be in charge of synchronizing our service mesh policies to every remote zone that we want to support. Like I said, a remote zone can be a cloud, can be a Kubernetes cluster, can be anything. And we can also mix and match virtual machine-based workloads with Kubernetes workloads. So I do have a setup here running simultaneously on two different clouds. One is AWS EC2 on virtual machines, and then I also have 3 GKE clusters running on GCP. We're going to be having one global control plane on GCP, and then 2 remotes, Kuma East and Kuma West on Kubernetes, and another remote on AWS EC2. So we can see here that there is a remote running on virtual machines, and inside of these clusters, we also have a control plane of Kuma running in remote mode. Now, I've deployed a demo application that demonstrates how we can increment a counter on Redis. So there is a demo app and a Redis app deployed on AWS, and we do have a demo app and a Redis service being deployed on each one of these clusters as well. So if I connect to the global control plane and we look at the Kuma GUI, we can see how we have all the workloads connected to the control plane. So I'm going to be exposing the Kuma control plane from our global cluster on Kuma system. And by doing so, I'm going to be loading up my browser. Kuma, by the way, also provides a RESTful API. So the GUI, it's just built on top of this RESTful API. And by loading at the GUI, we can see that we're running on 3 different zones. One, it's running on virtual machines on AWS and 2 GCP zones. And we're going to be having the demo app and the Redis app being replicated across both AWS and these GKE clusters. So we can see here that we have all the data planes online. One, it's Redis running on AWS. Then we have the demo app running on AWS, as well as we have the Redis running on GKE East, as well as we have the demo app running on GKE East and West and so on. So we've effectively replicated the same application across each one of these different environments. Now, let's go ahead and, for example, load the application from AWS and see what happens. So if I do load this application on port 5000, I'm bypassing the data plane right now, just so I can show you the demo application, and I increment the counter, we see how the demo app on AWS is incrementing the Redis that also runs on AWS. But let's demonstrate the multi-zone feature that Kuma provides. And so if we do enable mutual TLS and the traffic permission policies, we can now activate this multi-zone connectivity out of the box. Now, Kuma will automatically discover, based on the routing policies that we have set up, if we should be routing the request into the same zone or in another zone, regardless if we run Kubernetes containers or if we run virtual machines. So I do have a default mesh, as you can see here, and this default mesh doesn't have mutual TLS enabled. So we must enable mutual TLS in order to enable this cross-zone connectivity. To do that, we can explore the policies that Kuma provides, and we can see that among them, there is a mutual TLS policy. Now, the mutual TLS policy, it's a very simple policy. It allows us to provision a certificate authority either automatically or by providing our own certificates. And then on top of this, it's going to allow us to assign a certificate to every data plane proxy and also automatically rotate those certificates with no user intervention. So in this case, in this example, I am going to be updating my default mesh to enable the CA1 backend, which is of type built-in, which means we create the root certificate and key, and it will rotate the certificates every day. Applying zero trust security, it's this easy with Kuma. So I'm going to be echoing this command so I can provide the kubectl apply command that I need to run in order to enable this mutual TLS. And I'm going to be doing this next to my demo application to show you that as soon as we enable zero trust security, the connections will stop working. And that is because we must apply a traffic permission ACL in order to re-enable these connections to work again. So we go to our policies again, and among them, we see that there is a traffic permission policy. Traffic permission allows us to determine what source of traffic it is going to be allowed to consume what destination. And we determine that based on the attributes that Kuma applies on top of each workload that it's part of the mesh. And of course, we can also customize these attributes to have very fine-grained policies applied on top of Kuma. So in this case, I'm going to be saying, I want every service to be able to consume every other service. Simple as that. And if I prepare this command for kubectl, and I just do this next to our demo application. So basically, I'm just copying and pasting the policy so that it applies on top of the global control plane, we're seeing how the traffic will resume automatically, but most importantly, it will go from one zone to another. What we're seeing right now, it's something very exciting. We have enabled multi-zone connectivity across different clouds in a hybrid VM and Kubernetes environments with zero trust security and traffic permission ACL. We've done this in less than 5 minutes. This is how simple and easy it is to use Kuma. Now, let's say that we want to force our traffic to not be load balanced across each one of these different zones, but to be redirected to one zone in particular. We can apply another policy called traffic route, and with traffic route, we can determine, again, what source of traffic we want, what is the traffic path that we want to configure, and how this traffic path should be routed across our cluster. So I'm just going to copy and paste this real quick in order to show you how we can route our requests from one region to another. So let's say that we want every traffic being generated by, oh, and by the way, I forgot to, let me port forward our GUI again. I shut it down. Let me show you how we can redirect all traffic that goes from virtual machines to a specific cluster into Kubernetes. So we want to apply this route on all traffic that goes from the demo app to Redis. And any traffic that goes from the demo app to Redis must go to the Redis in one specific zone. For example, GKE East. Simple as that. We can remove this other policy, this other configuration, and then we can generate the command that we're going to be applying. So let's pull up the demo again. As you can see, it's still load balanced across every zone. So what I'm going to be doing is apply this new policy. And as I do that, we can see that our traffic will be redirected and routed all the way to our GKE East region. As you can see here, right now, in one policy, we've done a data center traffic shift in one command from virtual machines to one specific cluster of Kubernetes. But of course, we can always change that. And if we want, for example, all of this traffic to go to the West region, we can still do that with one command. So I'm going to be updating my routing rule so that this traffic will now go all the way to West. And then, of course, if we want to load balance a little bit on West and a little bit on East, we can also do that. So I'm applying a weight of 50 for each one of these rules. And if I update my routing rule again, we're going to be seeing a little bit of GKE West and a little bit of GKE East. This is how simple it is to run a distributed service mesh across every application in our organization. There was lots of effort that went into this underlying foundation to make sure that it would be this easy, this simple, and this intuitive. So this is a very short demo. If you want to explore Kuma more in depth, don't forget to look at our sessions and workshops, which will go a little bit deeper into all the policies and all the features that Kuma provides out of the box so that we can create a service mesh in just a few minutes across every cloud and every environment. Today, we've learned about the importance of connectivity across any modern architecture. We have discovered our new product, Kong Connect, delivered as a service to provide connectivity for every cloud and every platform. And we have seen the new version of Kuma 1.0, the universal service mesh to enable connectivity across multiple zones and multiple regions. But we're not done yet. I would like to invite Augusto back on camera to join me.
As Kong tradition, we have one more thing for you, like in every summit. Today, we unveil Kong Embedded. Kong Embedded runs local on any device, minimal footprint, and is data plane only. It's part of our R&D program, and it's invitation only. Kong Embedded can run on ARM device and support MQTT. It doesn't need any internet connection. It's a very simple data plane as the beginning of your journey of IoT, connecting all kinds of devices inside your company and at home. Please, let's see Shane how he's doing at his house.
So here I have a Raspberry Pi Zero W. Now for those that are unfamiliar with this particular bit of hardware, this little device is running a 32-bit ARM CPU at about 1 gigahertz, has about half a gig of memory on it as well. And in fact, it's using so little power, I'm just powering it from a portable USB pack. This is obviously fairly non-standard hardware for enterprise servers and enterprise systems. But one thing that we are seeing is that more and more servers or enterprises are moving in the direction of ARM CPUs, both for at-edge devices as well as for server workloads. That's both for decreasing overall energy consumption and the cost of ownership. And this particular little embedded device is actually running Kong Enterprise in an embedded mode. I think it really goes to highlight some of the major benefits that we often hear customers talk about when using the Kong Gateway. And that's really that because Kong can run on virtually any device and run virtually anywhere and run with a very low CPU and memory cost, it means that you can process far more instructions, far more requests per second on the same hardware and really do so on any enterprise hardware of your choosing. So we'll just go ahead and show here that we are running Kong on this device. And that it's using a declarative config, which means that we're using this as part of the way that we're running in our embedded mode. You can see that the database is turned off. And what I think is interesting is by having such an efficient low power profile, Kong Gateway opens up sort of entirely new classes of options. We can run the gateway straight on devices on the edge like this, which means that we can route and secure things like maybe the local GPIO pins here, for example. And I'll just turn on maybe an LED, for example, locally. And those embedded devices can easily have access to the rest of, say, an IoT network. So I'm just going to copy and paste a network command here. We're going to read the state of a temperature sensor that's on premise here. Or maybe even go so far as to build and secure APIs for something like, I don't know, the garage door, which allows us to really control and embed these, this high-power gateway directly on these low-power devices at the edge. And we're really excited to see what you sort of think of to use Kong Embedded for. So thanks.
As you can see, even Shane is able to turn on the lights or open his garage door by using Kong Embedded. It's not that hard, huh? The possibilities are endless. And as we've seen today, this journey of connectivity really never ends. We're powering all kinds of connections, giving you a reliability grid, and we're building connectivity for everyone. Please enjoy the next few days where we're going to go through amazing workshop, even new product announcements, and we're going to make you the superhero of connectivity.